which is decision making and looping. In our last meeting, chapter number 3, we discussed about the programming constructs of C# programming language, where we talk about the keywords, the variables, data types, operators, different types of operators. And in the lab session, we try to solve some programs, some 2 programs where we implement a problem to find area of circle. Just a minute, let me put this on recording. Okay, now this is on recording. So today, inshallah, we're gonna take chapter number 4, which is decision making and looping. Chapter number 3 gives us a clear idea about writing a program in C#. We can solve or we can write any program in C#, which is a sequential program. And we did wrote 2 programs. One is to find area of circle, and the other is to get the proof of one of the Pythagoras theorem, which is sine square x plus cos square x is equal to 1, which we did in our last meeting. Now in today's meeting, we are discussing further about decision making and looping in programming. Those who have taken other programming course like Java or any other programming language, they are aware of this decision making and looping. And this decision making and looping is to write our program in more effective way, in which we can select different type of data, and based on some conditions, some equations, we can execute some statements based on some conditions or some decisions. Or sometimes we need to repeat a number of statements for a number of time to solve any problem. So that we use looping. So decision making and looping, the chapter objectives are explain the decision statements in C#, explain iteration statements in C#, describe break, continue, and go to statements. Right. Now, before we start this decision making, I just want to bring a scenario in front of you. Basically, a C# program is a set of statements that are normally executed sequentially as they appear. So the execution is line by line. We have seen our one of our program that when we wrote a program to find area of circle, right, that the execution goes line by line. Fine. So let me just show you that again by sharing the screen. Here I can switch to the Microsoft Visual Studio, and I'll show you here that how the execution goes. The execution goes line by line, right? So for example, let's say that we are to find area of circle. We did this in our last last lab session. Let me just repeat this: double radius, and we ask the user console.write enter radius of circle, and for this radius we are gonna find the area. So we read it, convert dot to int 32, or let's convert into double because it is double, to double of console dot read line. We are going to convert this. Now we are going to just apply the formula that area is equal to math.pi multiplied by radius, which is radius square, and we got the area. And now we'll just print that area as console dot write line. The area of circle is area. So it's very simple that we are printing the area of circle by entering the radius. So the execution goes first the declaration, then it will ask the user to enter the area of circle, and it goes to ask the it goes to calculate the area, and finally it goes to print the area of circle. So let's say I enter 2.5, I get the area of circle here. Okay, and we have seen that we can round this to some decimal points by using round function. All right, so now the execution here is line by line. Fine. Now what if, like for example, area of circle is what? It is the radius square and multiplied by the pi. Okay. Now when we have a circle, the circle radius is always a positive number, which is greater than 0. If the radius is 0, there is no circle. If the radius is negative, there is no circle with negative radius. Right? So what is the radius? Is this the center of the circle? And this is the circle. This is what the radius is. Now, radius is always greater than 0, right? If the radius is less than 0, then there is no circle with radius less than 0 or minus radius. Fine. So we don't have any circle with minus radius. Radius is always greater than 0. So now what if in our program, if we enter, let's say if we enter a negative value, let's say for example minus 2.3 as the radius, we still have the area of the circle, which is wrong. So we need to do something here, that when we enter the radius invalid input or an invalid value like the negative or less than 0, then we should not do this calculations. We should just say that there is the radius is invalid. All right, so how we can do that is what we are going to learn today in decision making. Okay, so this involves a kind of decision making to see whether a particular condition has occurred or not, that is the radius is greater than 0 or not. Then direct the computer to execute certain statements according to the condition that what we are going to specify. Yes, brother, do you have any question? Any question? Great. If no questions, better.
Yes.
That's it. Is there any question, please?
Yes.
Yes, go ahead with your question, please. I think it's no.
دكتور
Yes, please.
في واجب الألمس موقع
الواجب خلاص هنا we are going to discuss إن شاء الله أي سؤال غير التوبيك اللي أنا شغال فيه فإن شاء الله في آخر المحاضرة إن شاء الله we'll talk about it. تمام. If you have any questions related to what we are discussing, please you can ask. Otherwise, all these questions keep it at the end of the lecture. Inshallah, we will discuss that. Okay. Thank you. So in this decision making and branching statement, we have a certain statements in C#. Okay. So the branching statements is when a program breaks the sequential flow and jumps to another part of the code. It is called branching. And when the branching is based on a particular condition, then we call it as a conditional branching. And if it is not based on any condition or without any decision, it is called unconditional branching. So we have two types of branching. One is based on some condition, based on some statement, which is, for example, if the radius is greater than 0, we do calculate the area and we print the area. If not, we don't print it, right? So the execution, the calculation of the area is based on this, that radius is greater than 0. So this is called conditional branching. Whereas in some way that we don't check any condition, rather we jump to some statement in our program, that is called unconditional branching. So C# language process decision making capabilities and support the following statements, which are called control or decision making statements, which are the if statements, switch statement, conditional operator statement. Conditional operator statement we did discuss in our last meeting when we were discussing about the operators. We did discuss about it, the conditional statement, the question mark and the colon, the conditional statement. Okay, anyhow, we're just gonna go through it inshallah in the coming slides. So we have three type of decision making and branching statements or decision control statements, which are if statement, switch statement, and conditional operator statement. To start with the if statement may be implemented in different forms, whether it is the simplest if statement, if else statement, if else if ladder, or in nested if statement. These implementation is based on the situation, is based on the requirement of the program in the program. So it depends on is based on what we want to do, whether it is possible to do our program with just simply using simple if statement, or we need if else, or we need if else if ladder, or we need to go through nested if else. It depends on the requirement of the program and what we need in the program. We use based on it the if statements, one of the following if statements. Okay, so basically we have these four different forms of if statements: simple if else statement, if else if ladder, and nested if statement. Fine, we start with a simple if. A simple if is very simple. It's a two-way decision statement and used in conjunction with the expression of the form if the expression. This expression should be a Boolean expression. This expression should be a Boolean expression, which means this expression must return either true or false. This should return either true or false. Okay, so that means we are going to put this statement, this expression in the if, right, that gives us the value either true or false after solving this expression. For example, if the radius is greater than 0, so if the radius is greater than 0, if r is, for example, 2.3, this is true, right? So this returns true. And if r is minus 2.3, this returns false, right? So we need to have the expression, such as expression that gives us a Boolean result or a Boolean value, whether true or false. So it goes like this. The if checks the condition. If the condition is true, it executes some conditional code based on this true condition. If not, if the condition is false, it skips this statement and continue with the next statement after skipping this part. Okay. Now, it's very simple to understand. Let's take our program here that we want to check whether the radius is greater than 0. So if we say that if the radius is greater than 0, we are gonna do this, that we calculate the area and we print the area. Okay. Otherwise, we simply do nothing. Okay, and we just, for the purpose of testing, let's say just we put a statement called thank you. Fine. Now in this case, when we enter the radius, it checks after entering the radius, the expression here is a Boolean expression. It checks whether the radius is greater than 0 or not, right? So if it is 0 or if it is greater than 0, this becomes true. If this is true, it gets into this block, the if block. Okay, calculate the area and print the area. And if this is false, it skips this if block and goes to the next statement after the block. Okay, now let us just simply test this with some values. I'm just going to give you first a positive value, let's say 2.3. So we have area of circle and we have thank you. Why? Because this goes to find the area and after this print thank you. So 2.3 is greater than 0, so it gets in, calculate the area, print the area and continues to the next statement, which is thank you. Now what if we enter a negative value, 2.3? So it just have a thank you. Why? Because the condition becomes false here, that radius is greater than 0 becomes false. Once it is false, it is skip the if block, right, and go to the thank you. This is the simplest if, what is called the simplest if, right? If the condition is true, we execute the if block. If not, then we just skip the if block and continue to the statement after the if block. This is the very simplest form of it. Okay, so this is how the general form is if the Boolean expression what we had, for example, radius is greater than 0, the statement blocks, that is you can add one statement, more than one statement, and we just simply say that okay, we calculate the area and we print the area, and then we have other statements after this block. Okay, when the condition is true, it executes this if block and continue to the next statements. And if the condition is false, it jumps this, skip this if block and continue to the next statement after the if block. If block ends here, that is with the opening of bracket and closing of bracket. This is the if block. Okay, the condition true, this block will be executed. That's what we have seen in our program, that if this is true, this will be executed. Okay, otherwise that will be skipped. So we have other example here to check the number is greater than 5. If the number is less than 5, we add this number 5 to the number, and if the number is less than 5, okay, if just let's say for example number is 10 less than 5 is false, so we just skip this and comes here. And if let's say here number is 2, so it goes 2 less than 5 true, it comes in add 5. Okay. Another example, so here the expression is true and here the expression is false. Okay, so this is the code for it. You can try this code or you can try that area of circle program also, just to understand how the things are working. Moving ahead, the if else statement. The if else statement says we have the another block, which is the else block. The else block is executed when the condition or the expression becomes false. Okay, so it says that if the expression is true, we execute this if block, and if the expression is false, we are going to skip the if block and execute the else block. Fine. Now, if this is true, we are going to execute this if block and skip the else block, come to the next statement after the if else. And if this is false, we are going to skip this if block and execute the else block and continue to the next statement after the if else block. Right. Now, why we need else, why we need if else is that sometimes we want to give the user a response, or sometimes in different conditions we need to execute different statements. Okay. If you take this example, what we are doing here is that when we enter a negative value, let's say for example minus 2.3, it says just thank you, but we don't understand why this gives thank you and why there is no area. There is no proper message here that what is happening, okay, to the user. Of course, we are the programmer, we are writing, we know that, but when the user is using such programs, we enter the negative value, it says thank you. So what is happening? Why there is no area, right? So here a proper way is that we can give some message here by adding else. That is, if the condition is false, we can just simply write to the user that invalid radius, or you can say radius cannot be negative, radius cannot be negative value, or we can say radius must be greater than 0. Some statement that gives a clear idea to the user that what happened and why I'm not getting the radius, why I'm not getting the area after I enter the radius. Okay, so this is else block is a false block. When the condition become false, the else block is executed and the statement goes, the next statement will be uh, executed. And if the condition is true, the if block is executed and the else is skipped and goes to execute the next statement after the if else block. So now let us run this and see for different values. Let's say for a positive value, it gives us the radius, the area, and prints thank you, right? So it is skipping that else block. Fine. And now let us enter the negative value. We get the message invalid radius, or radius must be greater than 0. Thank you. So it is skipping that if block, okay, and printing thank you. In all the cases, the thank you statement is printed because thank you statement is out of the if else block. It is not inside the if else block. It is out of the if else block, this thank you statement. So in all cases, this statement is executed. Okay, so this forms the if else block. If the condition is true, the if block is executed. If it is false, the else block is executed. Okay, so in all cases, either of these will be executed, but not both. It will be either of any of these two statements, but not both, right? So this is the if else statement. Okay, we have here if the number is less than 5, we add 5 to the number, else we add minus 5 to the number. Okay, so if the expression is true, this will be executed, if block, and skipping the else block. And if the expression is false, it will skip the if block and execute the else block and comes code after the if else block. Okay, this is how the if else statement works. So if Boolean expression is true, then true block is executed. That is the if block. True block here, it means if block. Otherwise, the false block, that is the else block, is executed. In either case, either block, true block, that is the if block, or false block, that is the else block, will be executed, but not both. Okay, in both cases the control is transferred to the statement X, which is the last statement, where we have the thank you statement in our case. So here is an example. We're using if and else, and we have the statement after the if else. Okay, so this is a if else statement. So we have taken if statement and the if else statement. Moving ahead, if we have a multiple conditions to test and execute one of the many blocks of code, if else if statements are used. So there are more than one conditions to check, right? For example, we want to print the grade of a student based on his marks. If the marks is between 50 to 57, we say grade B. If the marks is between 65 to 58 to 65, we say grade C. If the marks is 66 to 73, we say grade C plus. If the marks is 74 to 81, we say grade B. If the marks is 82 to 89, B plus. If the marks is 90 and above, we say A, grade A. Now here we have multiple conditions to check. After the user enter the marks, there are multiple conditions to check, right? Whether it is 90 and above, or it is between 82 and 89, or if it is between 74 to 81, or if it is between 67 to 73, and so on, right? So this a number of conditions we check. Okay, either of these condition is true, any one of these conditions will be true, and hence the grade can be printed. Fine. So there we're going to use the if else if ladder. If else if ladder. For example, we check this: if the number is less than 5, we print number is less than 5, or if it is greater than 5, it is greater than 5, else it is equal to 5. If not less than, not greater than, it means equal to 5. Okay, so we see that if, else if, and finally else. So if the first condition is true, the first true block will be executed, that is the if block will be executed, and it will jump here any statement after the if else. This is complete if else block, if else ladder block. Then if the first condition is false, then it will skip it and comes to check the second condition. If this is true, the second block is executed, okay, and skipping the third block and comes to the statement after the if else block. And if both are false, if this is also false, then the last else block is executed, and then it goes to the next statement after the if else ladder block.
Doctor, I have a question.
Yes, please.
So in if else if we have more than two decisions, right?
Yes.
And the last decision must be else, or else if is correct also.
Second decision or last?
Last one.
No, the last is else block. This should be there in the last. Why? Because if none of these condition is true, the last else will be executed. Okay, so it depends on number of conditions. In this example, we have two conditions, right? We have two conditions. Fine. The last is just else. Why? Because this is false and this is false, and obviously when two are false, the third is true, right? So we don't need to check any condition here. We just say else block, right? This comes under this if. If this is false, then the else block is executed. So we don't need to write again the third if here. Okay. So it is just two conditions. You might have more than one, more than two. Like what just I said, if the grade is, if the marks is greater than 90, 90 greater than or equal to 90, grade A, or something like this. Okay, so if you just like, let's just test it here. I'll just take some marks here, right, just to give you an idea, and we try to do it like how does it work. So I'll say like I'll ask the user double marks, and I'll ask the user that to enter the marks. Console.write enter the student marks to print the grade. So I'll just read that into the marks. Marks is equal to convert dot to double console dot read line. So I'll just read. Now we got the marks. Now this is where we check if the marks is greater than or equal to 90, right? So what we are going to do, we just say console dot write line grade A. Now here comes the else if. Why you need else if is that we have another condition. If the marks is greater than 90, it's okay. We print grade A, and it comes out and say that okay, we are you got grade A and finish. Right? Now if not this, then we check the next condition is that if the marks is greater than it is greater than 84 and marks less than 89. So it is between 84 and 89. Okay, we say console dot write line grade B plus. Right? So the third, we have another option that if the marks is greater than 80 greater than 74 and marks is less than 84, right? So this is what we say console dot write line grade B. Okay. Let's similarly we are going to add if else if else if else. Fine. When we reach to the marks below 50, right, or let's say that 74 is the last and after 74 73 is fail, here we don't need to check because anything below 73 or below 74 is fail. So we just simply say else and we'll say that console dot write line of grade F. I'm just skipping here. For example, we have the C, C plus, C and D, but I'm just for testing purpose, like just to show you that how the if else if ladder works. Now if the marks is, let's say that it's greater than or equal to 90, then it will print grade A and come out of this if else if ladder. And if there is any statement, like for example console.write line thank you, this statement of thank you will be printed. Okay. Now what if I enter the marks like for example 85. So this condition is true, marks is less than greater than 84 and it is less than 89. So it is true, print grade B and simply come here and print thank you. And what if the marks is let's say 80. So it comes here, the first condition is false, second condition is false, third condition is true, that is 80 is between 74 and 84, right? It is 83 or 84. Okay, then we print grade B. What if I enter 70 or 50 or any number less than 74? None of the condition is true, So it comes directly here to the else and print grade F and print thank you. Okay, so this is how the if else if ladder works. So let's test it, this program. Just like for example, I enter 90, it prints me grade A and thank you. I enter for example 89, it prints me grade F. Sorry, it should be grade less than 90. It should be here. So if it is 89, grade B plus. Okay, and what if it is, let's say for example 83, it is grade B, and anything less than 74, let's say for example 50, grade F. Fine. So now we see that we have multiple conditions to check, and every condition is is branched here, that only one of these conditions will be true at any time. If all these conditions are false, the last else block will be executed. Okay, so it not necessarily only three if statement, it can be any number of statement. For example, if you want to add more here for C plus, for C, D, you can add, right? You can add hundreds of if else, if else, if else. Depends on the requirement. What is your program? It depends on what you are doing in the program, right? So that's how the if else if ladder works. Okay, I hope this also clears your doubt. Is it clear? Welcome. Fine. So moving ahead, there is an example here. This is also a very good example, right? It gives you an options. It's a menu and says press 1 for addition, press 2 for subtraction, press 3 for multiplication, and 4 for division. It asks you to enter two numbers, number 1, number 2, first number, second number, and enter your option that what you want to do. You want to add these two numbers, subtract these two numbers, multiply these two numbers, or divide these two numbers. Okay, and based on your option 1, 2, 3, 4, that will be taken into this variable option OPT. Okay, based on this option, we are going to check if the option is 1, that is add, the result is add, and we print that addition. If the option is 2, else if the option is 2, if not 1, we check for 2. If 2, we do the subtraction and print the subtraction else. If not 2, else if option is 3, we multiply and print it. If not 3, else if option is 4, we divide it and print it. If not 4, let's say that user enter 5, 6, 7, 8, which is not an option here, then else we say invalid option, try again. And there is something called go to label. So there is a label here, right? What is this label? The label is a mark here that go to label will simply jump this cursor, the control from here, from go to the label here, and start from again from here. So in case if the user enter 5, 6, 7, 8, any number other than these numbers, then it goes to the else, says invalid, and says go to label, go to this label. This is unconditional decision or transfer. Here there is no condition to take the control back to the here, back to the label here, or to the beginning. Without any condition, just say go to. This is what the unconditional transfer of the control, without any condition. Okay, otherwise if you enter for example let's say 4, then this will be executed and it just simply come out and stop the program. If you enter any invalid value, and it goes take you back here. Okay, so you can try this program back at home and try to add one more option. You add this go to label in every option here. In option 1, after this printing, go to label, go to label, go to label here, and go to label here, like what is there here. Okay, and try one more option here, console.writeLine, press 5 to exit, press 5 to exit and add a else if option is equal to 5, then open the bracket and say console.writeLine, thank you for using calculator. That's it. It will come out. So we can add one more option here as what? As an exit option, and we can keep this, repeat this program till we press that exit option. Okay, so this is like a challenge for you to try that. Okay, simply by adding an option 5 here to exit, and in that option we add here else if. Before this else we add one more else if option is equal to 5, open the bracket and say thank you for using calculator. That's it. Then it will come out and directly say, don't add go to label there. Okay, it will come out directly here. In all other cases, add go to label, because it will repeat again. If you enter first one, it will show the plus, and go to label will take to the beginning again. So it will repeat from again for the next calculations, and so on. So every time you enter the numbers, every time you press any option, multiplication or subtraction, it will give you that. Okay, so take this as an exercise program, and do it at home to just make it more clear for you how to use the else if ladder. This is one of the output of it. This is how you get the menu, and you enter the numbers, you enter the option for this division, so you get the division here. Fine. Similarly, we can use this to find, let's say for example, the greater of two numbers, greater of three numbers, the largest of two numbers, largest of three numbers. Okay, so in here, for example, enter two numbers and find which is the greater. Okay, nested if. Coming to the nested if inside a if statement, we call it as a nested if. Any if inside another if, we call it as a nested if. Okay, so for example, if condition, and inside this if block we add another condition, and else. This else relates to the nearest if, and this else is to this if, because this if block, okay, we have another. This is called the nested if. The nested if inside another if is called the nested if. Nested if can be used to find the largest of three numbers. For example, we have three numbers and we want to find which is the largest of these three numbers. So we can check that if the first number is greater than the second number. If this is true, then we check if the first is greater than third, and if first is greater than second and greater than third, then we say first is the largest number. Otherwise, the third is the largest number in this case. Why? Because first is greater than second and first is greater than third. First is largest. First is greater than second. First is less than third. It means it is automatically greater than, the third is greater than second, right? So third is the largest. Now if this else is with this if, the nearest if, and now the next if, for example, let's say that first is not greater than second, first is less than second, then we simply test whether the second is greater than third. So we check if else, if second is greater than third, we say second is the largest, otherwise third is the largest. Okay, this is also a nested if. So nested if is if inside another if, we call it as an nested if. This can be used wherever it is required. For example, finding largest of three numbers, or any such conditions where we want to test, we need to check more than one condition. Okay, if this particular condition is true, we go to check other conditions, right? So in that case, we can use this if else if, nested if. Okay, fine. Tea, half cup. Anyone, no problem. Okay. Thank you. Okay, so moving ahead, the switch statement. Switch statement is very simple, and it's very similar to the if ladder. In the switch statement, we are not going to use this expression as a Boolean expression. This expression must give as a value, whether it is an integer value, a number, or it can be a character or any other value. This expression must give as a value, right? Whereas in the if else, the expression, what we say, this should be a Boolean expression that gives us true or false. But in the switch, it is also a conditional statement, but this is uses a value. Okay, the switch is a multi-way decision statement where we select a particular block or a statement to be executed based on some values, based on some value. Okay, and switch has the cases for every value. For example, if this value, the expression has a value, if this value matches with this value 1, then this block is executed, and break, it means break the switch, come out of the switch. And if not matching with this, the next case will be checked. And if this is matching, this block will be executed, and break will break it and come out of this. If none of the cases is matching, then the default block will be executed, and break will bring the statement out of the switch. Okay, so switch, the flowchart for the switch is given here, and we can implement the same program of the multiplication, division, and all in by using the switch. Okay, so I'll let us just put this in the Microsoft Visual Studio. I'll try to just copy this because it's a long code. It takes some time from us, so it's better that I'll copy this here so that we can do it. To copy and paste it here so that it will not take much time from us. Okay, just comment it here, paste it here. Oh, sorry. Let me just delete it. Okay, and let me continue this, the switch. And I'll paste it here. This, fine. what's happening here is that I'm using switch here, right? So this is the menu, what I get, and 1, 2, 3, 4, enter the first number, second number, and enter your option out of this 1, 2, 3, 4. Now we are going to switch the option. It's a value, right? The option is a value, either it is 1, 2, 3, 4, or any other value. Now this value, we're going to put it in the cases. Case 1, if it is 1 is pressed, then we add them and display the addition and say break. Break, it means break the switch and come out of the switch here. Okay, I'll add a statement here and just to say console.writeLine thank you. Okay. And if we enter 2, for example, the division, so it will go and check for case 1. 1 is not equal to 2, so it will just go for the next case. And it's 2, case 2 is matching with this option 2. Then it will do the subtraction and break. We'll simply break it and come out here and say thank you. Break the switch and come out. Similarly, if I enter 3, it will go for case 3. And when I enter 4, it will go for case 4. When I enter any value other than these 1, 2, 3, 4, then it will simply go to the default and say invalid option, go to label. So it will take to the label here and continue the execution again from here. Okay, let's simply try this and see what results we get here for different options. So here is the menu. 1 for addition, 2 for subtraction, right? So enter the first number. So for example, I enter the first number 10, second number 20, enter your option, let's say 1. So I have 10 plus 23, 30, sorry, and thank you, right? So it's done. So it adds these two numbers, break will break the switch and simply bring me here. The control comes here, say thank you, and the program ends here, okay? If I enter, for example, 10, 20, and I say second option, it is the result, done. And if I enter, let's say, for example, 10, 20, and the option is 4, we got the result, done. And what if I enter, for example, let's say 5. So it says 5, 5, two numbers. Enter your option. Option is 5. It says invalid option. Please try again. It takes me menu again. Enter the first number, second number. Right? Now how it is happening? Right? For example, I enter now 5, 5, and the option is 4. Division. Thank you. Done. Right? So when I enter 5, it comes here, option 5, and check for case 5. There is no case 5. It goes to the default and prints this and say go to label. Go to label, take the control here, and it starts execution from here again. Okay.
So Dr. Go to is a loop.
Yeah, go to is just unconditional jump, where we want to jump from one place to another place in our program without checking any condition. In some places like this, we want to jump. So it is in a conditional, what do you say, a jump statement from one place to another. So
instead of label, I can put go to like case 1 and we will do.
yeah, you can put like that. You can put any label here. Okay. You can put any label, any name, any keyword, like any identifier you can use except the keywords. Okay, as if like variable names you are using. Okay, you follow that instructions of variable. Similarly, you can add any label here. Test 1, test 2, or jump 1, jump 2. Okay. Programmers use these labels. They want to test something, they want to do some testing and all. The programmers usually use these labels, go to and all. Okay. Okay. Now let's just do this go to label that we want to repeatedly, we want to add another option of exit, and console dot write line of press 5 to exit. Now we are going to add option 5, case 5 here, case 5, and we just simply say in case 5 that thank you for using calculator, or thank you, and just come out. Console.write line and just say thank you for using calculator, and we just come out. We just say break. Okay. Now all other options we want to repeat it. Like if we want to repeat it every time we enter option 1 and we did addition, and then again we want to continue from the menu, we just simply say go to label. That's it. We add this go to label in every statement. Okay, and we continue it. Go to label and go to label. Fine, every statement. So we don't need here break. That's why it is given here as a green, that it will not reach, because if you are using go to, break will not reach here, right? So option 5 we'll keep it like this, an invalid option we'll keep it like this. Okay, so now let us run this, and for example we want 5 first number, second number 5, we want first option addition. So this is the addition what we have, and we have the menu again, right? Enter the first number 10, 20, option 3 multiplication, we have 10, 20, 200, menu again. Okay, and 5 to exit, and any other number, for example 6, invalid number, sorry, 6, and the option 6, invalid option, menu again. Now for example first number 10, 20, and I don't want anything, I just want exit 5, exit. Thank you for using calculator, and thank you again. That is the last statement what we have here. Okay, now in this case the break is unreachable. Why? Because every time it goes to the go to, this break will never execute, because we are using go to label. Okay, I just used it here just to give you an idea about, you can use the go tos and all. Now about the default statement, default should be the last statement after all cases is been tested. The last will be the default, and default can have a break or cannot have a break. It's an optional for default to have a break or to not have any break. Okay, now let me just remove this go to label, and let us test the break and without break. Any case with break and with no break, what will happen? Okay. Option 5, thank you for using invalid option. Okay, now we have the break. In every case there is a break, fine, and we have 5 cases, 1, 5, number 5 option for exit, and so on. Okay, now let us see that for example we don't have a break for case 1. There is no break here for case 1, and we select the case 1 option. We have here control cannot fall through from one of the case table, case 1 to another one, because of there is no break. There is no break. There is an inbuilt error. Continue. Even if we execute this, for example, first number is 10, second number is 20, and I enter the first option in which there is no break, right? So what did happen? It goes to menu again. It goes to menu again. Okay, because it went to the last, to the beginning of the program again. Fine. So there is some error here. There is some error which is, running the program abrupt or in a wrong fashion.
Doctor, it should, when there is no break, it should go to case 2, right? And do case 1 and 2 together. Then will it will break.
Until it finds the what is called the break statement, that is in Java, right?
Yes, I think yes, in Java.
Yeah, in Java it is like that. Yeah, but here it is not the case. It takes you to the beginning of the program, right? It is not the same case here. It takes you to the beginning of the program again. Okay, so we have to make sure that there is a break here for every case so that the program executes properly. The program works properly. So this is the switch statement, where this is how the switch works. We can use switch, and if else if ladder. Fine. We can, interchangeably we can use this switch and if else if. Okay. We also have here, for example, switch statement to check a character is oval or not. So we ask the user to enter in character, and we convert this character to the lower to a lower character, and we check every character of oval. If it is A oval, E oval, and so on. Okay. What if, for example, if I want to bring all cases, let's say for example A, E, I, O, U, all cases in one statement? That can be done. First you write case A, then you write case E, then you write case, at the end you write console.writeLine oval and break. Okay, and then we have a default that says not an oval and break. Break is optional here. If you add a break here, if you don't add, this will just come out of the switch. Okay, the break is optional here. So that's about the switch statement. Okay, so we have taken these if else, simple if else if ladder, nested if, and the switch statement. Moving ahead to the conditional operator, we have taken this conditional operator in our last meeting when we discussed about the operators. Okay, so it's very simple that we use a ternary operator, or it's also called a conditional operator. It uses question mark and a colon as an operator. The expressions are based on the condition. These expressions are taken based on the condition. If the condition is true, the first expression is executed, will be assigned. Here will be taken to a variable where we assign or will be printed. And if the condition is false, in that case, the second expression will be taken. Right? I did show you in the last meeting by taking an example. We can still have this example. For example, if a number is Boolean or not. So if a number is odd or even, okay, if it is a even or not. So if the number is 2, we'll take a Boolean variable is even. Number mod 2 is equal to 0. If this is true, the true value, that is the true, will be assigned to is even. Otherwise, if this is false, then the false value will be assigned to is even. Okay. So if you look back into the previous lecture, that we have taken example of printing whether it is a even number or odd number by taking a string variable. Okay. Fine. The if else and the conditional operator, we can use the interchangeably. If else with a conditional operator. Sometimes in the exams they'll ask like this: They'll give a conditional operator and ask you to write this in using if else, or they give an if else and ask you to write by using conditional operator. Okay. So you have to be ready for that by practice. So you can do some practice for this, and by taking some example programs, so that you'll be ready for that. So this is about the decision making statement. We have taken if else, if ladder, nested if, switch, conditional. These are the some of the these are the conditional or decision making statement or branching statements. Okay. Moving ahead to the looping statements. The looping statements are used to repeat a number of repeat a block or a set of statements or a statement a number of times. Right? Any instruction that you want to repeat, for example, 10 times, 20 times, 100 times, 1000 times, right? That we can use by using the looping statements. Okay. So there are different looping statements that we are gonna talk here, inshallah, or discuss here, inshallah. So here that looping is a process of repeatedly executing a block, okay, a block of statements or a statement, right? It can be executed a number of times, okay, from 0 to infinite number, or if it goes to an infinite number, fine. For example, the loop does not stop; it is executing, executing, executing. There is no condition that to stop the loop, or there is no statement to stop the loop. Then that is an infinite loop. Okay. If the loop continues forever, it is called infinite loop. C# supports such looping features to enable us to develop concise program containing the repetitive process. So a program loop therefore consists of two segments. One is called the body of the loop, the other is called the control statement that controls the loop. Right? The body of the loop is executed number of times, but there should be a control statement to control the loop to be executed a finite number of times. For example, 10 times, 20 times, 5 times, okay, or until some particular condition becomes false or a particular condition becomes true. Okay, so there should be a control statement to control the loop, and at some particular time the loop will stop, otherwise the loop goes infinite, and this infinite loop can create problems within the system where the program is running. Okay, so the loop should have the control statement and the body of the state loop. The control statement tests certain condition and that directs repeated execution of the statement which is inside the body of the loop. Depending on the position of the control statement in the loop, a control structure may be classified either entry control loop or exit control loop. So that means the loop can be classified as entry controlled loop or exit controlled loop. Now, when we say the loop is entry controlled and when we say the loop is exit controlled, entry controlled loop is when the control conditions are tested before the start of the loop execution. That means first we test the condition, then we start executing the body of the loop. If the condition is not satisfied, the body of the loop will not be executed. In such cases, we call it as an entry controlled loop. That means the entry to the execution of the loop. For example, this is the loop body and we have a condition here. Before this loop body is executed. So this condition is tested. If this is true, for example, then this will be executed. Otherwise, it will never repeat this. Right? So this is what we call entry control loop. We are controlling the loop at the beginning, okay, at the start of the loop. So this is called entry control loop. And in case of exit control loop, the test is performed, this condition test is performed at the end of the body of the loop, and therefore the body is executed unconditionally for the first time. That means we have the body of the loop and the test condition is here. The test condition is at the end of the body of the loop. So that means the control comes in here, execute this body, and then checks the condition. If it is false, it's come out of the loop. That means that the body of the loop is executed unconditionally for the first time, and then it goes to check the condition. That means even if the first time the condition is false, the loop body is executed. So in this case, the loop body is executed at least once. Okay, and in the first case, the entry control, the loop body is executed only the condition is true. Only the condition is true. Okay, so this is what is called exit control loop. The loop is controlled on exit from the body of the loop. Okay, so the test condition should be carefully stated in order to perform the desired number of loop execution. That is the test condition. We need to carefully write the test condition so that the loop will execute a number of time, finite number of time, and it will not go infinite loop. Okay, so entry control loop example is here. First test the condition. If the condition is true, execute it, and again it goes to repeat the loop to test the condition, and it goes on. And if it is false, come out of the loop if the condition is false. And in exit control, first the body of the loop is executed, then it will check the condition. If the condition is true, again repeat this loop, and if the condition is false, exit from the loop. So once the condition becomes false, the loop is executed. In both the cases, we see that there should be a time that this condition becomes false so that we come out of the loop and continue the execution of our program or stop the program, right? At some time, these conditions must become false, otherwise the loop will go infinite. The simplest form of the loop is the while loop, where we test the condition. While this condition is true, execute the body of the loop and continue checking the condition until this condition becomes false. Once this condition becomes false, just come out of the loop. Okay, so this condition is, we need some initialization for this condition to be done, which will be done here, and this condition must be modified inside the body of the loop. All right, because if it remains same, if this condition remains same, the loop will be infinite loop. Okay, so for example, this loop, if you check this loop, we have the loop control variable I. This variable I is called loop control variable, and loop control variable, or this condition, will be checked every time the loop is repeated. Okay, so it is an entry controlled loop because first we are checking the condition. So I is 1 here. If I is less than or equal to 3, which is true, right, and comes in and say welcome to while loop iteration 1. Now here you see this I plus plus. What is this I plus plus? Students, what is this I plus plus?
You will add 1 to the
increment.
An increment, add 1 to the I variable, right? So I was 1 here. Now let us track the I was 1 here. Plus plus will make I 2, right? Now this is the loop block, right? So it goes again to check the while condition. While I is less than or equal to 3. I is what? 2. 2 less than or equal to 3. Again true. Again print this statement, welcome to while loop iteration 2 here. The value of I is here 2 now. Okay, this one. And then increment I becomes 3 here. It goes 3 less than or equal to 3. True, because it is equal, right? True. Print this statement. Then increment I becomes 4 here. 4, it goes again. 4 less than or equal to 3 is false. Once it is false, Now it will come out of the loop here, and there is no statement to execute. The program stops here. Okay, so this loop is repeated how many times? 3 times. The body is repeated 3 times. What is the last value of I? 4. Okay, now this statement I plus plus makes the loop to exit or to stop after repeating it 3 times. What if we don't include this statement? I remains 1 every time. I is 1, 1 less than 3, print this. I is 1, 1 less than 3, print this. It goes on printing. In such loop we call it as an infinite loop. Okay, whether in this case the operating system will take care of it and see that if there is something is happening, such kind of things, the operating system will stop it, or the system will go crash, right? So if we do like this, for example, we write such programs and we say that while we create some infinite loops while true, and we repeat some statements. Let's say that inside this body of the statement, we use the system memory, lot of system memory. We store some files, opening more than one file in that, and do a lot of things inside this while block. Then what happens? The loop is executing. It takes all the memory of the system. At one time, the memory stack get full, and there is a chance that system will go crash, or there is a chance that the operating system, if it is there is a security, will stop this program, right? So this is a kind of virus initially which is created. People used to create a kind of virus that they write some program that takes all the memory of the system, and they create an executable file of such programs, and they simply send these executable files and make it run automatically. So when these programs run automatically, it takes all the memory of the system, and the system goes crash, or system will stop, well, system will hang, right? So that's the other thing. Fine. So what we see here is that this statement is the one which makes the loop to run 3 times and stop the loop. Otherwise, if we don't include such a statement, then the loop will go off. So that means that this loop control variable will be altered in some way, that the loop will exit after some finite number of repetitions. Okay, so this is the while loop. Similarly, if you want to add numbers from 1 to 5, sum of numbers from 1 to 5, right, we can use a while loop, and we see start I from I less than or equal to 5, sum is equal to sum plus I, so 1, then 1 plus 0, then sum will be 1. So you can trace this. For example, let's say what is the value of I, what is the value of sum after every iteration. I starts at 1, sum 0 here, right? It comes to here, the first condition is true, gets in, sum plus I is equal to sum plus is equal to I. It means sum is equal to sum plus I. Sum is 0, 0 plus I. 0 plus 1 is 1. I plus plus I becomes 2. So it goes again, 2 less than 5. It is 2, right? 2 less than 5, true. Now it is sum plus I. So what is sum? 1. 1 plus 2, 3. Right? Again add I. 1 to the I. I becomes 3. 3 less than 5, true. So sum plus I. 3 plus 3 is 6. And I becomes 4. Again it goes 4 less than 5, true. Sum plus I. 4 plus 6, it is 10. I becomes 5. 5 less than 5, less than or equal to 5, true. So sum plus I. 10 plus 15 is sum, 15. I becomes 6. 6 less than 5 is false. Once it becomes false, come out of the loop and print the sum, which is 15. So this is the output. Okay, finding the sum of numbers can be like this. Okay, try to do this program. Find the sum of numbers from between two numbers. Okay, ask the user to enter two numbers. Let's say, for example, 10, 20. Now, what is the sum of numbers between 10 and 20? So I must start from 10 and goes to 20. And every time we add this I to the sum. Right? Try to do this program just to practice this looping. Okay, it will be interesting, inshallah. Similarly, for example, if you want to print a series of numbers like odd numbers, even numbers, right? We can do that by using the looping. Like here, this example prints odd numbers 1, 3, 5, 7 up to 10. Similarly, if we want to print even numbers, okay, we start n from 2, for example. So 2 plus 2 will be 4. Instead of 1, if we start from 2, it will be 2 plus 2, 4, 2, 4, 6, 8, and so on. Okay, the loop ends at once n becomes 10 or greater than 10. So this is the while loop we have. Okay, we have another loop which is called do while loop. Do while loop is an exit control loop, whereas the while loop is an entry control loop. Do while loop is an exit control loop. Do while is an exit control loop. In the do while loop, first the body of this statement or the body of the loop is executed, then the condition is being tested. Okay, so you can see this program which prints a table of a multiplication table of 5. Okay, we start from here. Do these are the initializations. Ni number is 5. Do find the product of n in and print this n multiplied by 5 and add 1 to I, increment I. Now we check at the end of this while I is greater than or equal to 10, and we put a semicolon here to show the end of the while loop, end of the do while loop. Okay, so it goes again. If this condition is true, it repeats the loop again. Once this condition becomes false, it comes out of the loop. Okay, this is called exit control loop. Okay, so you can find the difference between while and do while loop. While loop is an entry control, whereas do while is exit control. While loop, the first condition is checked in the while loop. So if the condition is false at the first time itself, the loop body is never executed. In the do while loop, if the condition is false at the first iteration, even the loop body is executed once, or the loop body is executed at least once, even the condition is false at the first time in the do while loop. Okay, so this is the difference between while and the do while loop, and you can use these while and the do while, okay, interchangeably. Depends on the requirement where we need this to use. Okay, so these were while and the do while loop. We have the third loop which is called for loop. The for loop. Now in the while loop and the do while loop, what you have seen, the loop operator, sorry, the loop control variable, like for example here the n, and in this case I. In this case I, we check the I, we increment the I, right? We initialize the I, test the condition on I, and we increment the I, right? So I is a loop control variable. Once I becomes 6 or greater than 5, we stop the loop, right? Similarly here also I, we initialize the I, test the I, we increment the I. And in this program, n is the loop control variable. We check n, initialize n, check n, and we do increment or decrement n. We take action on n so that the loop will exit. Okay, so these three things in the for loop is being given in one statement, in one line, that is a for loop. Okay, so we see that initialization, for example, I is equal to 1, the test condition I less than or equal to 5, and the increment I plus plus is given in the one statement here, and the rest is included in the body of the statement. And this is for the for loop, and this is another entry control loop. because first the condition is tested before executing the body. So this is another entry control loop. Okay, so the execution of the for loop is very simple. First it will come and initialize the loop variable. Then this is the first step, right? Then it will go to check the condition, the second step. Let me put it again. The first step is that it will come in, this is the initialization is done. Then after that, the second is to test the condition. If this condition is true, let me put it here. If it is true, it will comes in, execute the body, and then goes to the increment or decrement, whatever here, whether it is increment or decrement, we make the change to the conditional variable, the loop variable, loop control variable. So we do it, for example, here I plus plus, let's say. Okay, so the third is executing the body of the loop, then the fourth is incrementing this or decrement, whatever. Then it goes to the second again, okay, to test the condition. If it is true, execute the body, again does the increment, and then test the condition. Once this condition become false, it will come out of the loop body. This is how the for loop is executed. So we can write, for example, if we have a program using while loop, we can write the same using the for loop. Okay, we can write it interchangeably. So let's do it a simple program here, just to add numbers, from 1 to 5. So I'll say int I is equal to 1, and we have sum is equal to 0, right? So we said like while I is less than or equal to 5, what we did is that we said sum plus equals I, that is sum is equal to sum plus I, and we said I plus plus, and finally out of the loop here are console dot write line the sum of numbers, or the sum is okay. So simple statement just to print a sum of numbers from 1 to 5. So we'll get the sum is 15 from 1 to 5. The same we can put it by using the for loop, right? So in the for loop, initialization can be done I is equal to 1, the testing I is less than or equal to 5, the increment or decrement, whatever the action you want to take on the loop control variable, okay, and just does the rest of the statement sum plus is equal to I, or sum is equal to sum plus I, okay, and we print this sum. Okay, let me just comment this, and we just execute this for loop. It does the same job. Okay, so we see this initialization and condition and the increment decrement output in one statement, that is the for loop. Okay, that variable we call it as a loop control variable. The variable I what we used here, okay, is called the loop control variable. Okay, so here we have a for loop that is executing 5 times. Okay, that is the loop body is executed 5 times, 0 to 5, right? Printing the numbers in the reverse order, that is we start from 10 and we decrement here 10, 9, 8, 7, 6, every time -1, and print the I until 10 goes less than 0 or 0. So there is a comparison between while, do while, and for loop. So it's very clear that what is the difference between them, right? So that's about the for loop. Now jumps in the loop, that we want to jump from one place to another. We have seen that label jump, that is a label jump is by using the go to statement, go to label, right, in our program. Here we have that label, and we use that go to label, right? This is go to jump. That is, we are jumping from a place to another place in our program. So we have other types of jump like break and go to. Break, we have this break. This break we used in the switch, right? To break the switch and come out of the switch. Break can also be used in looping, in for loop, in while loop, that will break the loop and come out of the loop completely. It will just break the loop and come out of the loop. Okay. And if you want to skip some part of the loop and continue the loop, we can use the continue. Okay, skipping part of the loop and continue the loop, we can use a continue statement. Okay, we'll see some examples for them. Like for example, break statement. In the switch statement, we have seen that break, right? To break the switch and come out of the switch. And in the loop, we can break. For example, if you see this code, we are trying to print the numbers from 10 to 20. But we said like if the number goes greater than 15, break. Okay. Otherwise, it is just print the number and continue. Print the number and continue. Right? Let me put it here for you. So it's we have int number is equal to 10, and we said while number is less than or equal to 20. So we check if the number, if the n is greater than 15. If it goes above 15, we simply say break. Otherwise, what we are doing is we are just writing that number console.writeLine, and we say that or this is a number n. Okay, and we are just simply incrementing the n. This is break. Spelling mistake it is. Fine. So here we see that it goes, for example, it goes n is 10, 10 less than 20, true, n is greater than 15, no, false. So it will skip this if block. This is a simple if, and just print the number, and n becomes 11. Check the condition. When n becomes 16, 16 greater than 15, true, break, is just break it and come out here. And if you have any statement here, let's say for example, thank you will be printed. So now you see here 10, 11, 12, 13, 14, 15, thank you. There is no 16, there is no number after 15. Why? Because when n goes above, it break will break the loop and come out of the loop. So in some cases in our programs that we want to break the loop based on some conditions, if the value goes to particular, if the variable takes particular value, we want to break the loop, then we can use this break statement. So break can be used to break the statement. Similarly here, it is printing from 1 to 4. When the value becomes 5, it is breaking the loop. Okay. Now continue statement is somewhat like break statement. The break statement breaks the loop, whereas the continue statement will skip that value and continue from the next value, from the next value of the loop control variable. Okay, from the next iteration. So if I say continue here, okay, when n becomes greater than 15, or let's say that if n is equal to 15, it will say continue. That means that it will not do this job. It will just go here to do continue here. Okay, now in this case I need to add this somewhere here so that n will change after this. So let me put it here, and now let us run this. We see that no, we should skip this 15. Oh, it is printing here. Printing should be there in here. Yeah. Printing should be here, because when it says continue, it will take to the beginning of the loop again. Okay, with new value of n, right? So printing should be at the end. So now you see that 15 is skipped here, right? Why is because of continue. So when it comes to 15, n becomes 15. It says if this condition becomes true, continue will take the cursor back to the loop control, the loop condition with a new value, okay, and goes to the 16. Fine. So if not, it will go on printing those values. Fine. So continue is that the forces the next iteration of the loop to take place, skipping any code in between. Okay, for example here, if a is equal to 12, continue will just simply take the a value here, okay, without skipping all this statement. Okay, fine. Now go to and label. We have seen the go to and the label, right? So for example, go to loop 1. If this condition is true, it will take to the loop 1. Loop 1 says continue, so it will continue from the loop 1. Otherwise termination by break. Okay, this code will give you this output, this code. Okay, although we are repeating this loop 1 and loop 200 times, because of this break, these conditions, it will not go 100 times, it will go only for 10 times because of this break. Okay, so go to label we have used. Fine. So these are about the labels we have. So fine. So this is all what we have for you in this chapter number 4, decision making and looping. So this includes decision structures such as if statements. So we have seen simple if else, if ladder, nested if. We have seen the switch statement, conditional operator, and then we talk about the looping statements, the while loop, the do while loop, and the for loop, entry controlled and exit controlled, and then we talk about the jumping statements, break, continue, and go to label. Okay, so this is all what we have in chapter number 4. If you have any questions, please go ahead.